Tennessee state standard is to verify experimentally the properties of rotations, reflections, and translations. Lines are taken to lines and line segments to line segments of the same length. Angles are taken to angles of the same measure. Parallel lines are taken to parallel lines. Another standard for today is to describe the effect of dilations, translations, rotations, and reflections on two-dimensional figures using coordinates. And today we are focusing on rotations. Your lesson objective: I can find the coordinates of a figure after a rotation of 90 degrees, 180 degrees, or 270 degrees clockwise or counterclockwise. So you'll need to pause the video and write that down. All right, triangle ABC has vertices negative 7, 3, B, A, negative 7, 3, B, negative 2, 5, and C, negative 4, 1. We have done a 90-degree clockwise rotation, so let's see what our vertices are for triangle A prime, B prime, C prime. So for A, it is positive 1, 2, 3, positive 1, 2, 3, 4, 5, 6, 7. So 3, 7. For B, it is positive 1, 2, 3, 4, 5, positive 1, 2. So 5, 2. And for C, it is positive 1, 2, 3, 4. And so we talked yesterday about how these coordinates compare to the original coordinates and to the actual 90-degree clockwise rotation. And the rule for the 90-degree clockwise rotation, or 270 degrees counterclockwise, because those are the same, the rule is you switch X and Y and then change the sign of the new Y. So switch X and Y, then change the sign of the new Y. Now let's go back and look at that to see if that's what happened. So we switch X and Y to become 3, negative 7, and then change the sign of the new Y, so it becomes positive 7. Switch, so you have 5, negative 2, and then change the negative to a positive. Switch, so it's 1, negative 4, and then change the sign of the Y to positive. All right. 180-degree rotation, triangle ABC has vertices 3, 5, 5, 2, and 1, 1. After a 180-degree rotation, you can see it over in quadrant 3. So let's list those coordinates. So A would be negative 1, 2, 3, negative 1, 2, 3, 4, 5. B is negative 1, 2, 3, 4, 5, negative 1, 2. And C is negative 1, negative 1. And yesterday we talked about this as well. And we talked about what a rule might be comparing A to A prime for 180-degree rotation. Our rule is change the signs on both the X and Y values. Just changing the signs. You don't change them around at all. You just change the signs. So let's see if that's what we did. So 5, 2 becomes negative 5, negative 2. 1, 1 becomes negative 1, negative 1. So that is what we did. All right, and finally, we're going to do a 90-degree counterclockwise rotation, which would also be 270 degrees clockwise. So A prime is negative 1, 2, 3, 4, 5, positive 3. So negative 5, 3. B is negative 1, 2, positive 1, 2, 3, 4, 5. So negative 2, positive 5. And then C prime is negative 1, positive 1. And we also discussed how a 90-degree counterclockwise rotation affects the original coordinates. And the rule for that is 90 degrees counterclockwise or 270-degree clockwise. You switch x and y, then you change the sign of the new x. Switch x and y, change the sign of the new x. So let's see if that's what we did. So switch x and y, 5, 3, and then change the new x, so that would be negative 5, 3. Switch x and y, so 2, 5, change the sign of the x, negative 2, 5. 1, 1, change, stays 1, 1, change the sign of the new x, which is negative 1. So this is one set of notes that you will definitely need to have out as you're doing your practice assignment tomorrow. All right, so now we're going to do one without the graph. Triangle ABC has vertices A, 5, 8, B, 1, 2, and C, let's see if I can see this, 6, 4. Give the coordinates if it is rotated 90 degrees clockwise. So let's see. So we switch x and y and change the sign of the new y. We switch x and y and change the sign of the new y. We switch x and y, change the sign of the new y. For 180 degrees, we just change the signs. So, negative 5, negative 8. B double prime is negative 1, negative 2. And C double prime is negative 6, negative 4. For a 90-degree counterclockwise rotation, a triple prime, we switch x and y and change the sign of the new x. Switch x and y, change the sign of the new x. Switch x and y, change the sign of the new x. So for a 90-degree clockwise rotation, I'm not going to do that because that might confuse you. We'll talk about it in class tomorrow. All right, let's try another one. Triangle ABC has vertices A, 2, negative 5, B, 5, negative 3, and C, 1, negative 4. Give the coordinates if triangle ABC is rotated 270 degrees clockwise. Above that, I want you to write 90 degrees counterclockwise, 90 degrees CCW. So it would be switch x and y and change the sign of the new x. Switch x and y, change the sign of the new x. Switch x and y, change the sign of the new x. 180 degrees, above that I want you to write CW clockwise. You can just write CW for clockwise equals CCW for counterclockwise. So all we do is change the signs. Negative 2, positive 5, negative 5, positive 3, negative 1, positive 4. And finally, 270 degrees counterclockwise, I want you to write above that 90 degrees clockwise, or CW. So we switch x and y and change the sign of the new y. Switch x and y, change the sign of the new y. Switch x and y and change the sign of the new y. So above 270 degrees clockwise, you should have 90 degrees CCW. Above 180, you should have CW equals CCW. And above 270 degrees counterclockwise, you should have 90 degrees CW. So, our Tennessee State Standard to verify experimentally the properties of rotations, reflections, and translations, that lines are taken to lines and line segments to line segments of the same length, that angles are taken to angles of the same measure, and that parallel lines are taken to parallel lines. And to describe the effect of dilations, translations, rotations, and reflections on two-dimensional figures using coordinates. And today we focused on rotations. And your lesson objective was to be able to find the coordinates of a figure after a rotation of 90 degrees, 180 degrees, or 270 degrees clockwise or counterclockwise. Have a great evening, and I will see you tomorrow.